Variables is defined as characteristic or attribute that can assume different values. Letters of alphabet such as X, Y, or Z denoted in capital letters are used to represent variables. Random variables is a variable whose value, which is a real number, depends on the outcome of random experiment. When we have an experiment, so the result of that experiment is called random variables. We usually denote random variables by capital letter and the particular value it takes by a small letter. So capital letter X, Y, R, and etc. is random variable, and the small letter is the value that can takes by the random variable. If we toss a coin twice, the number of hits obtained could be 0, 1, or 2. When we toss a coin, there are two possibilities, whether we get head or we get tails. So there are two coins, means number of head could be 0, both we get tails, no head at all, or one of the coin we get head and the other is tails, or both coin we get head. That's why the number of head obtained could be 0, 1, or 2. The probability of this occurring are as follows. No head means both are tails is 0.25. Probability of coin 1 get tails is 0.5 and coin 2 get tails is 0.5. So 0.5 times 0.5 is 0.25. And probability of one head, either one coin get head, either coin 1 get head or coin 2 get head. So probability of this occurring is 0.5. And probability of two heads means both coin 1 and coin 2 are heads, is 0.25. We can show the result in a table known as probability distribution tables, which is number of head, or this is a random variables X, 0, 1, and 2. Number of head is 0 means probability of getting no head, which is 0.25. Number of head 1 means probability of one head is 0.5, and number of head 2 means probability of getting two head 2 is 0.25. The variables being considered is the number of head obtained in two toasts, and it can be denoted by X. X equal to the number of head obtained in two toasts. It can only take exact value 0, 1, or 2, and so is called discrete random variables. The probabilities can be written as P x equal to 0 equal to 0.25. X equal to 0 means probability of no head here. And probability x equal to 1 equal to 0.5. X equal to 1, 0.5. And P x equal to 2 equal to 0.25. Discrete random variables is a random variable that can assume countable value, a whole number. Countable value is numbers that we use to count 0, 1, 2, and so on. Means discrete random variable cannot be negative and cannot be decimal. We do not count item as 1, 1.5, and 2. For examples, the number of students in KM-L. So students is person, and we have 0 student, 1 student, or 2 student, and so on. We do not have 1.5 student. So students can only be exact 1 or 2. There are no half or 3/4 student. Means this is a discrete variable. Number of cars sold in a month. So cars again is an item. We need to count as a whole. 1 car, 2 cars, or and so on. There are no 1.5 cars. And the number of accidents in a year. A random variable that assumes any values contained in one or more intervals is called a continuous random variable. For discrete, we have x equal to a number. For continuous random variable, instead of a number, X is in one interval from A to B. For example, the weight of a student. Weight, we have grams, kilograms, and hundreds of kilograms. And also we have 1 gram, 1.2 grams, 1.11 grams, and so on. Means this is a continuous numbers. The time taken to finish a race. Time is also a continuous random variables, as time can be second, minutes, hours. There is no one exact measurement for times. And the heights of a person. So heights also continuous random variables. We have centimeters, meters, inch, and so on. Means there are no one exact measurements for these variables. Examples. Indicate which of the following random variables are continuous or discrete. Life of a battery. Life of a battery means how long a battery can operate. Means we're looking for times. Times is continuous random variables. B. The number of new accounts opened at banks during a certain month. So number of account can be exact. 1 account, 2 accounts. There are no 1.5 accounts. So this is a discrete random variables. C. Time taken. Times is continuous. Price. Price. Again, we have ringgits and cents. So price is a continuous random variables. In other words, anything that have decimals is considered a continuous random variables. E. Total weight. Weight is a continuous random variables. Number of a student. So students is discrete. Times continuous. Height of a student is continuous. Number of rooms in a house. So number of rooms is 1 room, 2 rooms. There are no 1.5 rooms. So this is a discrete random variables. Probability distribution is a discrete random variables that lists all the possible values that the random variable can take and their corresponding probabilities. Two characteristics of a probability distribution of a discrete random variables are: probability of this random variable must be from 0 to 1. And second, total probability must equal to 1. Probability distribution fx equal to p, x equal to x can be given in the form of tables, mathematical formula, or graph. Example, a fair dice is thrown and the number on the dice is the random variable x. Construct a probability distribution table. So x equal to number on the dice, and x can take value. Number on dice is 1, 2, 3, 4, 5, 6. And probability of getting 1 out of 6 possible outcome is 1 out of 6. When we throw a dice, we get possibility we get 2 is also 1 out of 6 possible outcome. Probability of getting 3 is also 1 out of 6. 4 is 1 out of 6. And all possible value is 1 out of 6 possible outcome. Example 2. For the following probability distribution function, find the values of A. So probability x equal to ax. For x equal to 1, 2, 3, 4. This into a table. So x can take value 1, 2, 3, and 4. So probability of getting 1 is ax, where x is 1. So we get A. And x equal to 2 is 2a, and x equal to 3, 3a, and 4a. To find a, we know that total probability must equal to 1 since this is a discrete random variables. So total probability is total of a plus 2a plus 3a plus 4a equal to 1. So we get 10a equal to 1, a equal to 1 over 10. So we get a equal to 1 over 10. Example 3. Given the discrete random variable x has the following probability distribution function, gx, where p is a constant. Find the value of p, hence sketch the graph of gx. Find the value of p, we put this in probability distribution function, where x can take value 0, 1, 2, 3, 4. When x equal to 0, gx equal to 0. When x equal to 1, gx equal to 2p. And when x equal to 2, gx equal 4p. Substitute 2 into function. When x equal to 3, this is 3p. And when x equal to 4, this is 4p. With gx equal to 4p. We know that total probability must equal to 1. So adding all the probabilities is 2p plus 4p plus 3p plus 4p equal to 1. So we get p equal to 1 over 13. Then gx is 0. 2 times 1 over 13 is 2 over 13. 4 times 1 over 13 is 4 over 13. 3 over 13 and 4 over 13. Sketch the graph for gx is the value of x is 0, 1, 2, 3 and 4. And then the probabilities is gx is 1 over 13, 2 over 13, 3 over 13, 4 over 13, 5 over 13. And sketch graph, since this is a discrete random variable, means x can take exact value 0. So when x equal to 0, gx equal to 0 is here. When x equal to 1, gx is 2 over 13 is here. And since this is a discrete random variable, so x is a constant value. This is a straight line. And there's no graph in between 1 and 2. When x equal to 2, gx is 4 over 13 here. Again, this is a straight line. And when x equal to 3, 3 over 13. And when x equal to 4, 4 over 13 here. Okay. Graph for discrete random variables, and this must be in straight line.